Hello everyone, Namaste. I am Charles Pelleray and here is Esteban. We are both delegates from U3P, the French Union for the Promotion of Photonic Propulsion, and today we will present to you our proposal for an Asteroid Grand Tour competition, an orbital trajectory competition proposal.
Namaste. As of Okay. So, as of late April 2025, so a few weeks ago, about nearly 40,000 near-Earth objects have been discovered. So what's a near-Earth object is an asteroid, more less frequently a comet, that orbits the Earth very close to Earth's own orbit. So collision may be possible, causing important damage depending on the size or mass. Among them, almost 11,000 from a category called PHAs, potentially hazardous asteroids, that are really dangerous for us humans. These PHAs have a size of 140 meters at least, making them very dangerous. Any attempt of mitigation against an asteroid needs to know in advance their shape, composition, mass, size. These parameters cannot really be well defined from Earth, well observed with a good accuracy, but this is possible to do so using a satellite. So flyby missions could achieve precision with lightweight instruments. It's not a big deal. However, the high number, 11,000 is very high number of targets is a challenge, and we need to find new ways to observe and fly by these asteroids as much as possible, actually, in order to prevent collisions and to improve our knowledge on these near-Earth objects. That's why we propose a co-petition, we'll explain the term after, to engage with this issue.
So we have a lot of interest to visit the asteroids, but why visit them by solar sails? Let's see a few characteristics of solar sails, and we'll see that it's the most efficient way to explore as many asteroids as possible. So the basic of a solar sail is photonic pressure. As you know, photons or light quantums has no mass, but they still can give a momentum to a body, not by varying in speed, but by varying their wavelength. The asteroids are orbiting the Sun, and since our propulsion is proportional to illumination, since we are always illuminated, we have a continuous thrust. This thrust is really weak, really small, but it's continuous. It is a fundamental aspect of solar sails. As you can see with our diagram, the amplitude of the force and the direction of the force change with the sail attitude determination, which means they are also maneuverable. Few of you could say that solar sails are science fiction, but really it is not, and already has a great history of flight. We can cite Icarus, for example, who flew in 2011 around Venus, launched by JAXA. But most recently, We have lots of initiative with much smaller mass as CubeSat with LIGHTER 1 and 2 by the Planetary Society, or even last year with ASC3 by NASA. Another really important aspect of solar sails is that their performances depends not just of imported propellant mass, but a ratio of surface over mass. So that means even CubeSat could be very efficient even in interplanetary flights.
Okay, so what's a competition? As you may have already understood it, it's a mix between a competition and a cooperation. For the competition aspect, what we propose here as U3P association is to organize a competition. This competition will have a competition aspect because here we will have different teams of 2 to 4 students, for instance, competing against each other. Each team will have the opportunity to show, demonstrate its talent, and be rewarded with a prize. There's the already existing GTOC competition you may know about trajectory optimization, and we could organize these competitions based on this model, for instance. About the cooperation aspect, what we want to do is to share the starting parameters, all parameters like the date, location of solar sail time 0, and results on a common database for all participants to share and concept. This competition will typically have a duration of 24 hours, like a hackathon, and there could be different, at least we propose several competitions with each time we will change the initial parameters and do like so we will build different database based on different starting parameters. This shared database will allow us to determine the optimal configuration of the solar sail, surface to mass ratio, for instance, or different orbital parameters to optimize flybys for this mission. As Charles said earlier, solar sails have low thrust, so this limits their navigation capability. For instance, it's very difficult to change its inclination. That's why we propose to start by doing a 2D challenge. The competition will be in two dimensions. So the solar sails won't be in the plan, for instance here the ecliptic plan. This has also an advantage because students will be able to handle the challenge more easily because 3D is quite complicated. And here you have what we want to achieve. So this is a prototype of a tool for this competition. Here you have a solar sail trajectory with different asteroids crossing the ecliptic plane. So we will provide a tool at the beginning of the competition and also a database. So this database of PHAs, we're focusing only on PHAs. So this database will be composed of dates and location of PHAs when they are crossing the ecliptic plane. So this is at this moment that your solar sail that is in the ecliptic plane can fly by, of course. And the goal is to achieve a maximum of flybys on a given time span, which is part of the initial parameters. In the future, we could imagine 3D simulations to improve orbit determination and also the strategy, because you can fly by also by passing under or above the asteroid. So the 3D program would be another approach when we already have good 2D database.
So as U3P, we've made several simulation tools already. This one is, as an example, is our most advanced one. It is a Earth-Moon 3D solar cell simulation made by Alain Perret, former CNES engineer. And as all orbital maneuvers, it is based on the orbital equations, the Gaussian orbital equation of a perturbated body. And the simulation tool allows us to change dynamically during the simulation all characteristics of the sail, ratio of surface over mass, etc. And it's also made to optimize criteria of navigation, since you know solar sails don't have a punctual maneuver thrust, but a continuous which varies in amplitude according to the sun and satellite altitude, which is why simulation tools are very necessary for solar sails. And these tools can allow us to optimize the sail attitude for increasing or decreasing apogee, perigee, inclination, run, etc. And this tool could be a great base upon which to improve for a heliocentric reference frame with asteroids. Further stages could be done after the co-competition, so the sharing of our tool is a great part of our cooperation aspect of this competition. And we would need to continue to promote solar sails by writing and publishing courses on celestial mechanics and satellite conception, since unfortunately solar sails are still very unknown by the great public and engineers. We could also observe the asteroids that have been selected as targets via the competitions. We could even, with space student programs, build demonstration in the form of CubeSats, since cube satellites could also be very efficient even in interplanetary trajectories, and with a development oriented with the enlargement of the sail to increase the payload mass. And at the end, we could even launch clusters of spacecraft as secondary passengers of high altitude missions such as GEO Galileo, L2 or lunar missions. And the main great part of a cluster of satellites is that because where solar sails have a continuous thrust, we could automate the exploration of asteroids, and with that many asteroids, it is necessary to automate the gathering of data.
So, to conclude here, what we want to propose as U3P is a call for organizers. Actually, what we want to do is to have many organizers around the world using the same tools, of course, for fairness, and the same shared database. It could be U3P. We plan to, of course, organize our own 24 hours competition, hopefully this year. And we think that this format is actually quite interesting in order to promote certain propulsion that is still very unknown to almost everyone. And it's also, we think, a good opportunity for any space enthusiast to take part in hackathon-like event, because we plan to provide the tools, the database, the studies in 2D, and also mechanics, orbital mechanics courses. So it's not addressed to aerospace engineer students or specialized students. I think it's open to all the space enthusiasts to take part in, and yes, it's a good way also to promote photonic propulsion. That's why we are here as U3P delegates. Thank you everyone, and of course, if you have questions, we're more than happy to answer.
questions, please, to our young explorers.
When do you think this could be made, an allowance of the Grand Tour?
When the competition could be organized, as soon as possible. I think it's.
What's your estimate?
My estimate is.
What's your estimate of the time, the date when this could be implemented?
At the end of the year, I think we could do, or in autumn. In autumn, U3P wants to organize something special, and it might be a first 24-hour competition.
So you mean for the competition that you were talking about?
Yes.
The real flight?
Oh, a real flight, safe flight. Charles mentioned that winners of such competitions could take part in development of CubeSat, CubeSat, like the Payanque initiative. Payanque is an initiative that was launched by U3P a few years ago, and that is still ongoing independently, but still mentored by U3P. And the development has been doing quite well, and we're planning to finish the conception phase by the end of the year, and fully we could launch it next year. So it's a 7 by 7 meter solar cell to reach the moon.
Thank you.
Thank you for the question.
Okay, any other questions?
Anyone else?
Okay, none. So let's thank back the speakers once more.